we're going to discuss the angle bisector theorem. Angle bisector theorem is a pretty simple theorem that we're going to work with. All it tells us is that the bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the lengths of the sides adjacent to the angle. Okay, so what this is telling us is that we got some sort of angle that's being bisected. When it's being bisected, we know that it's going to split that angle into two equal angles. So in this case, I've got angle BAC being bisected. So it's being split by this line here, which is creating two congruent or equal angles right now. Okay, so we have this angle bisector. What it's telling us is that since we know those two angles are going to be equal, that we can say the ratio of the two side lengths opposite, which would be here. We have our angles. The opposite would be BD. And the opposite here would be DC. So we create this ratio of our opposite, which is BD, over our opposite, which is DC. And I'm going to write these two in blue here. Actually, you know what? I'm going to make this one red so we can see where it's coming from. So we've got our BD, BD over DC. And it's telling us that that ratio is now equal to the adjacent sides to the angle. So the ratio of the adjacent sides. So if we look at these, oh geez, my colors are all backwards. So I've got my BD is my blue. I've got my DC is my red. Okay, so now if I look at these, the adjacent sides of these angles, remember this angle, we're talking about these angles right in here. The adjacent side is going to be the side, not that they share, but the one next to the angles. So I've got two adjacent sides. Okay, for this first one, my adjacent side would be this angle here, this angle A, and down here is point B. So these should be equal to, so we've got AB, and which we'll put over, and I'll clean this up in a second, my adjacent side to this triangle, which would be AC. Now I put these in the different colors so that we could see where each side length is coming from. So we've got my opposite side of my smaller triangle and my adjacent side of my smaller triangle are both on top of those ratios. And then I've got my opposite side of my larger triangle, which we said was DC. And we're going to make that equal to my larger side of my top triangle. So that's what it's telling us, is we can create that ratio of opposite over opposite would be equal to adjacent over adjacent. Now let's see it with some actual numbers. Okay, so we've got these lines of congruency here. They're telling us that this is congruent to this. Okay, so we know this is an angle bisector. We know we've got two equal angles that are coming out here. Okay, and that bisector would be line CD. Now if I set up my ratios, remember it's going to be opposite over opposite. So we would have 12 over x, and I'm going to set those equal to adjacent over adjacent. So 18 over 24. And this is the relationship I want us to be able to see as well here, is that this x and this 24 both come from this triangle here. and this 12 and this 18 both come from this second triangle here. So we got to keep the same triangles on top, same triangles on the bottom. Okay, so now we've got something where we've got, let's see how this erases. Okay, we've got 12 over x is equal to 18 over 24. To solve this now for x, we're just going to do some cross multiplication. So we're going to cross multiply these two. 18 times x gives me 18x. And that'll be equal to 12 times 24. So we use all the geometry to set up the problem. And then now it's really just algebra to solve it. So 12 times 24 is going to give me 288, and that's going to be equal to 18x. To solve this one, all I got to do is divide by 18, and I will get that x is equal to 16. We can come back now and check that. If I plug in 16 for x down here, I've got 12 over 16 should be equal to 18 over 24. And if I check that, 12 over 16 reduces down to, reduces down to 3 over 4. So 12 over 16 reduces to 3 over 4. And 18 over 24 also reduces down to 3 over 4. So we can see I've got an equivalent ratio here. That's what I can use my angle bisector to solve.